Hello everyone, I am Shivam Pasari and welcome to ASIN Academy. So as you can see from the title of this video, in this video we'll solve another good question from the topic of number system, and the question has been taken from the CAT 2023 exam slot 2. Now the question is as follows: the number of positive integers less than 50 having exactly two distinct factors other than 1 and itself is. So I would like you to try this question first by yourself and then come back to the video for the solution. So let's start with the solution to our given problem. So according to our given question, we have to find the number of positive integers less than 50. So our sample space is from number 1 up to the number 49, having exactly two distinct factors other than 1 and itself. So basically, if the number has exactly two distinct factors other than 1 and itself, we can say that the number has total of 4 factors. So there are two approaches by which we can solve this question. So by the first approach, what we can do is we can list down all the numbers starting from 1 up to the number 49 and calculate the number of factors of the number, and whichever number has 4 factors, we count them. This is a very lengthy method and we have a shorter and much easier approach. Let's discuss approach number 2. So in approach number 2, we find all the numbers with 4 factors and then we count them. So when a number can have 4 factors? So a number can have 4 factors if it is of the form a cube, or it is of the form a raised to power 1 and into b raised to power 1. Now over here a and b are prime numbers. So we know that if a number is of the form a raised to power n, then the number of factors of that number is equal to n plus 1. If we have 3 as a power raised to the prime factor, then the number of factors is n plus 1. And same is the case with a raised to power 1 into b raised to power 1. The number of factors is equal to 2 into 2 because we have 1 plus 1 into 1 plus 1. So there are 4 factors. So if a number is of the form a cube or a raised to power 1 into b raised to power 1, where a and b are prime numbers, then it will have 4 factors. So let's list down all the numbers. So let's start with a cube. So what numbers can a take? And be careful that a must be a prime number. So a can take 2 because 2 cube is equal to 8. It is between the range. And a can take 3 as well because 3 cube 27 is in the range. Now a cannot take next prime number 5 because 5 cube is 125. So it is out of the range. So of the form a cube we have only 2 cube and 3 cube. So now let's move on to the form a raised to power 1 into b raised to power 1. So let's take the first case when a is equal to 2. So what are the values that b can take? So b can take 3, b can take 5, 7, 11, 13, 17, 19, 23, but it will not take the next higher prime number because that is equal to 29. So it will lift till 23. So we have 3, 5, 7, 11, 13, 17, 19 and 23. And over here we have total 8 numbers. Now the next case is a is equal to 3. So what are the values b will take? So b can take 5, 7, 11, 13, but it will not take 17 because it will be higher than the range. Now the next number we have is a is equal to 5, and the only prime number it can take is 7 because the next number will be out of the range. So the number of total numbers that we have is 1 plus 4 plus 8 plus 2 over here. So that is equal to 2 plus 8 plus 4 plus 1, that is equal to 15 numbers. So this was the shortcut method by which we can calculate the total number of numbers that have 4 factors.